In this video, we're going to review 5 questions that cover target 1D. We're going to start with question number 16, move on to 17, 18, 19, and we'll finish up with 20. So let's go ahead and start with number 16, and you'll see that I have a formula written over here. And what this means is that if we have two bases, in this case n, which are the same, then the exponents, which in this case are x and y, will be set equal to each other, right? So back to my problem here. I have 4 to the x power equals 32. Well, I want to rewrite this equation so that my bases are the same, if possible. So if I rewrite 32 so that it has a base of 1, well, let's think of all the possibilities. We could do 4 to the 1, for 4 to the first power, which is 4. We could do 4 to the second, which is 16. And we could do 4 to the third, which is going to be 64. None of these equal 32, so that's not going to work. So we have to take 4 then, which is our smaller number, and we want to rewrite that. So I know that I could take 4 and rewrite it as 2 squared, so I'm going to go ahead and do that. And we still have that x as our power. Now let's try 32 again. So we want a base of 2 now. So 2 to the first is of course 2. 2 squared is going to be 4. 2 cubed is 8. 2 to the fourth is going to be 16. 2 to the fifth is going to be 32. And that's what we wanted. So we're going to stick with 2's, and I'm going to change this then to 2 to the fifth power. Okay? Now our bases are the same. So I'm going to clean this up. I'm going to write it so we have one exponent. So when we have an exponent to another exponent, we multiply. So all I'm going to do is write 2, and then 2 times x is 2x. And that's going to equal 2 to the fifth power. Now our bases are the same, so we could ignore those and we can just do 2x equals 5. So I'm going to write 2x equals 5, and I'm going to solve that. So to undo the multiplication of 2, I divide it. 2 over 2 is just 1, so it cancels out. And I have to do the same thing to my right side. So now I'm left with x over here, which equals 5 halves, and that's going to be my final answer. One thing to keep in mind too, by the way, is we're not dividing this side and this side by 2 to cancel it out. That's not correct. I'm simply showing that 2 and 2 are the same bases, so then the exponents have to be equal to each other as well. So I'm just rewriting the exponents here, and that gave us the final answer. On to question number 17. We're going to do this one a little bit differently. First of all, I'm going to rewrite everything, x, and then I'm going to evaluate 25 to the 1/2 power. If I throw that into my calculator, I'm going to get a 5, right? 25 to the 1/2 power, by the way, is also the square root of 25 if you rewrite that in radical form. And then 256 to the 1/4 power is the same as 4. And to solve this then, all you have to do is undo the multiplication of 5, so I divide it. 5 over 5 is 1, so that goes away. And on the right side, we have to divide that as well. So I'm left with x equaling 4/5. And that's my final answer. And actually, if you're wondering how did this become 4, you could use your calculator, or if you want to rewrite that, it's going to be 256 to the first power, and this 4 gets swung around and it becomes the index of this. So the fourth root of 256 is also equal to 4. Okay, on to question number 18. And this is similar to number 16, where we had to find the same bases, right? So I have my formula here again, and I want to try to rewrite 27 so that it has the base of 3. So 3 to the first power is just going to be 3. 3 to the second power is going to be 9, so that's not going to work. 3 to the third power is going to be 27, so that actually works. So I'm going to rewrite 3, y divided by 7 minus 1 equals 3 to the third power. So now my bases of 3 are going to be the same. So if my bases are the same, I know that my exponents have to be the same. So I'm going to rewrite my exponents. It's going to be y divided by 7 minus 1. That's going to equal 3. And I just solve this. So I add 1 to the left side and to the right side. That goes away. I'm left with y over 7 equals 4. And then to undo the division of 7, I'm going to multiply this side by 7 because 7 over 7 goes away. And I need to multiply the right side by 7. So I'm left with a y equaling 28, and that's my final answer. On to question number 19. I have a word problem here. And we are trying to solve for x. So I'm going to write my equation with x here. That's going to be r equals 7 to the 4x power. And we can't solve for x as is because we don't know what r is. However, up here we're given r, right? Radius equals area divided by pi to the 1/2 power. So I'm going to plug this part into here. So I have area over pi. That's going to be raised to the 1/2 power. And then that's going to equal my 7 to the 4x power, right? Now that actually didn't help us too much because now we have a variable a, and we don't know what that is. So I look back to what I was given, and it does say that a equals 49 times pi. So I'm going to rewrite a, but instead I'm going to do 49 pi to take its place. In the denominator I still have pi, and then my exponent is still 1/2. On the right side I have 7 to the 4x power still. So now let's simplify some things. I see that I have pi over pi, so that goes away. And then I'm left over with 49 to the 1/2 power, which equals 7 to the 4x power. Now I'm going to rewrite 49 to the 1/2 power in radical form, and this 2 gets swung around. That's going to be the new index. So we're going to be doing the square root of 49 actually, or you can just use a calculator, plug in 49 to the 1/2 power. That's going to give us 7, just like the square root of 49 would be 7. And then that equals, still again, our 7 to the 4x power. Now, we have the same bases, so we can set the exponents equal to each other. The exponent on the left side is an invisible 1, so 7 and 7 are the same, so we can ignore those and just set our exponents equal to each other. So that's going to be 1 equals 4x. We can solve for x now. To undo the multiplication of 4, we want to divide it out. 4 over 4 gives us 1, so we got to divide the left side as well. And our final answer then is going to be x, and that's going to equal 1/4. Question number 20, another word problem. And we are going to be looking for time. So I'm going to rewrite my equation with time. That's going to be p equals 6.11 times t to the 1/5 power. Now we know that p equals 10.02 meters. So I'm going to plug that value in for p. So now we have 10.02 meters, which equals 6.11 times t to the 1/5 power. And at this point we have to solve, and that means we have to get our t part by itself. Once we get this by itself, then we'll deal with the 1/5 exponent. So to undo the multiplication of 6.11, we're going to divide it out. So that over that gives us 1. It goes away. We got to divide the left side by 6.11 as well. We're left with about 1.64. So that's going to be an approximation. But we do have our t to the 1/5 power by itself, and that's what we wanted. So to get rid of this, the exponent of 1/5, what I'm going to do is raise it to the 5th power, right? I'll explain why in a minute. So this left side gets raised to the 5th power 2. Now remember, whenever we have an exponent raised to another exponent, we multiply. So 1/5 times 5 is going to be 5 over 5, which is just 1. So on the right side here, I'm just left with t to the 1st power, right? And then that's going to be approximately 1.64 to the 5th power, which is about 11.86, and that's t, so that's going to be seconds. So that's going to be 11.86 seconds, and that's going to be my final answer. So to recap, we started off with question number 16, moved on to 17, did 18, and then 19 and 20 were both word problems.